good morning, everybody. It's a great honor to be here at gRP conference in India. And I'm also happy to see that this is the first gRPC conference happening in India. So it also proves how actively we Indians are contributing to the global gRPC ecosystem. So about my talk is AI inference pipelines, building low latency systems with gRPC. About me, my name is Akshat Sharma. I work at Deskree, where we enable AI to communicate to your entire system to get the unified context. Also about my background, I've cracked Google Summer of Code in the year 2024 with MIFO's initiative, and in the year 2025, I returned back there as a mentor, guiding new contributors about the open source ecosystem and contribution. I have also attended numerous conferences like KubeCon, Open Source Summit India, Intel as a Summit, Open SSF as well. So now let's start with our talk. So many of us have tried building AI models, and in production, we have noticed that a lot of characteristic changes. So why does that happen? It is because in production, AI is not about model training or optimization. It is also about AI inference pipeline that brings that model to our lives. Also, you guys have noticed that the difference between a fast model and a slow model is not the algorithm. It's about the data transfer, communication, and infra orchestration. From fraud detection to medical imaging, we have different edge cases where we can't afford any delays. And there, our gRPC shines because of its speed, efficiency, as well as streaming capabilities. So now let's talk about why every millisecond matters. So in the present world, every business, whether it's small or large, is utilizing AI in their daily workflows. And the single millisecond can mean the difference between a success as well as the failure. Also, user directly equate the inaccuracy with the delay, and thus the overall user experience get hampered. Now I will discuss some of the use cases where this millisecond plays a very crucial role. So the first one is in from the fintech industry, where we involve fraud detection. So in fraud detection, every millisecond delay could mean another fraudulent transaction slipping through and increasing the overall risk of the organization. Similarly, in healthcare sector, we have medical imaging. So there, as soon as the prediction will be made, the faster will be the diagnosis and the faster lives could be saved. And now let's talk about the user experience. So the e-commerce website is a good example where user experience plays a very crucial role. Similarly, in various social media platforms, we have recommendation systems. So if there will be some small delay, then a lot of things get changes, like the user experience and overall trust in the business. Thus, every millisecond matters a lot. Now let's talk about the difference between REST and gRPC. So REST has been the undisputed king in making of the web APIs due to its ease of use, was human readable, and was of standardized nature. But it is not optimized for high frequency machine to machine communication. And here, the REST is based on JSON as well as HTTP 1.1, which means each request sent creates a new connection or handshake. Also, here the data is very bulky and often need parsing. And also we don't have any of the streaming capabilities in REST. But gRPC is based on protocol buffers. And here the data is in binary form. Thus, the data here is lightweight as compared to REST, and the overall communication is very efficient. Similarly, a major drawback of REST is parsing overhead, and the another is head of line blocking, due to which multiple requests cannot travel through a single connection. Whereas gRPC supports multiplexing, so different requests can travel through the same communication channel without blocking each other. The another benefit of gRPC is it supports bidirectional streaming. Thus, making the overall process more efficient. And as a result, we have less overhead and thus we have less latency. Now let's talk about in more depth about the difference between REST and gRPC. So REST is the traditional protocol which is based on HTTP 1.1, whereas our gRPC is based on HTTP 2. Talking about the serialization format, so REST is based on JSON, which is text-based, whereas the gRPC is based on binary. The next feature is payload size. So due to text-based serialization format, the payload is usually very bulky here that affect the overall latency. Whereas in gRPC, it is compact. The next criteria is streaming support. So REST does not have any native streaming support, whereas our gRPC supports bidirectional streaming, making the overall process very efficient. And thus, based on these things, the latency of REST is higher, and the gRPC we have very much lower latency. And when we compare it to the benchmark, so it directly translates into 5 to 10 times lower latency. And that's before any model optimization. Now I will talk about the system architecture overview that we have deployed in our setup. So we have different layers. The first one is the client layer, then communication layer, followed by the inference layer, data layer, and monitoring and observability layer. So client layer involves web, mobile, and internal apps, API gateways, authentication, routing, and rate limiting. Jumping into the next layer, so our communication layer include persistent channels like HTTP2. We have service mesh, which includes Istio and Linkard, and we have smart load balancer, which is Envoy in our case. Also, we can use gRPC built-in smart load balancer as well. Now, let's talk about the third layer. So we have for the serving model, we have used TF serving, and the other alternatives that can be used here is Triton and Torch. Torch is from the PyTorch. The next thing we have in the inference layer is inference orchestrator, which includes batching and routing. And for the model cache, we have used Redis, and another good alternative is Memcache. Now, talking about the fourth layer, data and the feature layer. So we have feature store that we have used is Feast, and another good option is Hopsworks that we have tried and it also works absolutely fine for us. For the vector database, which is an optional requirement, but here we have used Milvus and Pinecone. Now, talking about the last layer we have is the monitoring and observability layer. So for metrics and logging, we have used Prometheus as well as Grafana. And for distributed tracing, we have used JGR and gRPC interceptors. And we have regular health checkups based on the different dashboards of Prometheus and Grafana. Now let's talk about some of the performance bottlenecks and their fixes that we have got in our analysis. So the first issue we have faced while using the REST protocol is serialization overhead with JSON. And this is directly eliminated by using the protocol buffers that we have in our gRPC. The another issue we have faced is slow response due to the blocking in the input and output operations. And our gRPC async streaming performs absolutely well, resolving this issue. And the last and important issue we have is unoptimized batch matching. And this issue we have resolved by implementing adaptive batching based on the load. Now I will talk about in more depth about observability and monitoring. So in order to make low latency AI inference pipelines, the main thing is visibility. You need entire visibility of your infrastructure so that appropriate action could be taken in case of any mishappening or misconfiguration. So due to it, we are majorly relying on these four things. The first one is Grafana, which is an open source thing which involve visualization. The next we have used is Prometheus for matrices. And the third is Jaguar that we have used for the distributed tracing. And the last we have used is Tetrix, which involves connecting directly to your code, infrastructure, and operations, giving you the full visibility of your entire system. So, based on these tools, we have got everything from visualization, throughput, request flow, and root cause analysis, and every misconfiguration can be handled with these four tools that we have used. Now, real world benchmarks are also a very important consideration. So, I will talk about two main things. The first is the NVIDIA Triton Inference Server with the gRPC, and the another thing is Google Cloud AI platform. So, NVIDIA Triton Inference Server also demonstrate 5 to 10x low latency compared to the traditional frameworks like Flask, REST under the similar conditions. Also, this performance gains majorly comes from three things. The first is the binary proto buffer serialization. And the reason of it is we have smaller payloads and thus the transmission is faster. The next thing is persistent HTTP2 streams. So it has no repeated handshakes, making the overall process more efficient and realistic. And the third thing is efficient GPU request batching for the parallelized inference. Thus, it is ideal for the high throughput inference workloads like fraud detection recommendation systems that we have discussed in the previous slide. Also, I'm happy to share that Google Cloud AI platform also use gRPC internally for model serving pipelines in order to achieve low latency and high throughput inference. It also enables efficient streaming and multi-model deployment across distributed nodes. And also, a major benefit of it is integrating well with the Kubernetes, Vertex AI, and TensorFlow serving for the scalable inference management. Thus, hyperscalers rely on gRPC for real-time AI, serving at a massive scale. Now I will talk about open source and community. So our implementation was based on open standards like gRPC, Protobuffer, Triton, Kubernetes that powers transparent, natural, neutral AI systems. Also, gRPC relies on the open source DNA built by Google and now under CNCF. And it is also receiving a massive contribution from multinational corporations like NVIDIA, Microsoft, as well as others. Also, another benefit of gRPC is we have continuous improvement through open issues, GitHub discussions, RFCs. Also, another benefit is its easily integrated nature with open frameworks like TensorFlow, PyTorch, Onyx. And thus, gRPC enables every developer, whether it is a newbie or very experienced developer, to access high performance inference technology in making different types of internal projects as well as massive open source projects. Now let's talk about what worked and what did not work in our case. So the things that worked very well is persistent connections, bidirectional streaming, and asynchronous handling. The persistent connection reuse the HTTP2 streams and reduce the connection overhead in order to achieve low latency in our system. Also, the bidirectional streaming works pretty well in our case and enabled real-time inference and continuous data flow in our systems. And the asynchronous handling also improved the concurrency and throughput under high load conditions. Some of the challenges or the things that does not work in our case is message marshalling overhead. So we have the serialization and deserialization process added a minor latency, but still it is very better as compared to the traditional protocols like REST or Flask. Also, the another thing that does not work and is also a challenge that is being issued currently is the limited browser compatibility. So currently, gRPC lacks the native support in browsers, and in order to access it, we need gRPC Web or REST fallback. Now, I will talk about the future of work that we are planning to work in the couple of months. So it includes majorly three things. The first is the multimodal inference routing. which involves dynamic selection and routing of the models based on context, user, and latency budgets. And we are also planning to use ensemble models and A/B serving via the gRPC orchestration. Also, we are planning to work on building the edge AI pipelines with the gRPC web in order to bring low latency inference closer to the end users through edge nodes. We are also planning to build some of the customized nodes that can overall improve the performance. And also, we are planning to work more on the gRPC web in order to get the browser and mobile compatibility without losing any of the performance. And we are also, in our roadmap, we are currently working on model optimization libraries and integrating it with gRPC. So majorly we involve ONX runtime, TensorRT, and OpenVINO for the adaptive model acceleration. And also we are working on the automated graph optimization and quantization during the deployment so that your AI model performs well in the local system as well as in the production. Now, here are the resources that I will definitely recommend you guys to check it out. It involves everything from model serving to gRPC infrastructure to data context and observability, as well as the case study that I have discussed. So let's build the low latency AI together, and every millisecond matters. So make your AI think and respond in real time. Also, I want to emphasize that making a real world AI model is not only about model training or better data, but it also involves the AI inference pipeline that brings that model to our lives. So this is all from my side. Thank you.
When you talk about like moving from JSON to gRPC, right? There was a part about batching. So, what are you using batching for gRPC?
Yeah, so we have made several batches based on different use cases, and we are directly using that based on the scenarios we have.
So, is like one gRPC message has these messages batched in them?
Yeah, yeah.
Okay.
So bi-directional streaming is different from.
Yeah, we have used binary thing.
Binary is just the format which goes
Yeah.
on the wire.
It is a data format.
I am from the admin background. I just know how to use JSON templates. Other than that, I don't know anything.
So bi-directional and streaming and all that is like how who can speak when. So if it's a unary, then the client can send one message, server sends one message, and then over. Like that's the protocol. Bi-directional streaming is like both can keep sending messages at the same time.
It is related to torch only.
So, do you face challenge because not all models are like you mentioned automated, right? Are you facing challenges like in doing a automated graph optimization and quantization?
Yeah, so it is in our roadmap, and we are planning and trying different things, reading several research papers in order to get the things
I
in a
just
better.
want to understand if you may your experience with using Torch Export, if you're using that for this purpose, because Torch claims 90% of the open source models they're able to export, but still for the custom models there are challenges. Do you also face it?
Yeah, so in our analysis till now, we have faced some of the drawbacks of it.